Welcome to the Øredev keynote chats for 2025. I'm Frederick, and as usual, we're publishing our keynote speaker chats from the conference as short episodes. This year, we're releasing all 6 at once, Netflix season style. Also, as usual, links to each keynote and all other relevant information can be found in the show notes. They are in your podcast player right now, or at kodsnack.se, Kodsnack. In this episode, it's Natalia Chepiga's turn to educate me a bit about the world of quantum computing. Natalia's keynote revolved around using simulations on plain old regular computers to build quantum computers. Yep, that's a thing you can do. This chat was before her keynote, which went really deep. In our discussion, we stayed a bit more general, talking about Natalia's way into quantum research, whether it's the next big hype, and where I might notice quantum computing first. Enjoy. So welcome to the smaller stage, Natalia.
Thanks a lot.
Preparing to head into the keynote. So I guess we'll try to not talk about that because people will see it soon. And
not spoil it.
No, exactly. And people who listen later will be able to watch it as well because the links will be there. But yeah, you do research in quantum.
Indeed.
That's cool.
Thank you, I agree.
Serious. Yeah. How did you get into that track?
You know, it was so natural, actually. I was interested in physics when I was 12. And then, in Eastern Europe, we always do this Olympiads competition. And it's kind of, for me, first time, it was really a chance to travel to see the country. But it was also cool to meet people who were interested in physics as much as I was. And then it's kind of naturally evolved into a bachelor and then master and then PhD. And then, maybe it's better to stop. But I didn't. So I just continued.
So it just came natural all the way.
Exactly.
That's wonderful. And the same thing about your research area, if you describe it.
Oh, okay. So I'm a physicist, theoretical physicist, doing quantum research, numerically, focusing mostly on the most difficult part of quantum physics, quantum phase transitions. So that's my area.
Yeah, nice and narrow.
Exactly. Yeah.
And the quantum part and the narrowing, did that come natural as well, or?
No, it's all quantum.
Okay, fair enough. That's what people say when they are into quantum, right? It's all quantum anyway.
It's all quantum, yeah. No, well, nature is quantum.
Yeah.
Right? So it's our approximation to consider it classical, but in fact, it's just approximation. Nature is quantum.
Yeah. So that's what we're going to hear something about in some way.
Absolutely.
In 20 minutes or so.
Yes.
I was at another conference a couple of weeks back, and I got the feeling that there's some sort of little wave building about quantum computing right now. Is that your impression?
That's exactly the topic of my talk, right? So quantum computers, we of course hope that will be a great complement to what we have now, to the classical capacity that we have, and we do our best to make this happen. But the truth is, and that's exactly what I'm going to talk in a few minutes, is that in order to optimize quantum computers, the cheaper way is to use classical computer now, right? So we can still cooperate and make essentially the life of each other much better.
Yeah. Oh, yeah. It's going to be really interesting because I'm curious about it because that presentation I watched was unfortunately kind of, I don't know, feels like a big company trying to sell something a little bit. So
look, I'm a scientist. I'm not selling anything.
No, exactly. That feels so good.
I produce knowledge and I just give it away.
Yeah, so I was wondering a little bit because that presentation made it feel like, we were trying to give the impression that something major is just around the corner, but the roadmap clear was pretty fuzzy. How close or far or something? When will I start noticing something? I guess.
Oh, but that depends on your expectation, as always.
Yeah.
Right? Because in principle, we already have something. We already can do research on quantum devices, but you should not expect too much of it. You should not expect it to enter your everyday life, right? So it's already there, but it's not yet our everyday business on the phone, etc. Yeah.
But you have uses for it in your work? Or will you have use for quantum computing in your work?
Yes, well, let's say not use, but cooperate with the experimental part of it, yes.
So will we get new interesting research made thanks to quantum computing becoming more powerful?
Absolutely. It's really about the power. It's about the accuracy of the simulation in general that we can reach. If with the old algorithms, classical algorithms, we could do that much. With new algorithms, we can do that much. And with quantum, essentially, we can do much more. And again, listen to the talk.
Yeah. Exciting stuff is coming. So, but I won't notice in my day job for a while, probably.
Again, it depends, right? So if you decide that your day job would be to play with quantum computers that already exist, then you will notice, right?
That's a slight pivot from where I am now. But should I be thinking about quantum computing?
Of course, because it's future.
Yeah.
But again, this is future that can only complement what we have now. It cannot replace what we have now.
Which is a very exciting kind of future.
It's reassuring for people sitting
here.
Yeah,
exactly.
Right?
I mean, it's so much nicer than when someone's saying, "Oh, this will replace everything," and you will be out of a job.
No.
And stuff like that. Yeah, we need more new things like that, I think.
Yeah.
Will I be able to do something cool with quantum computers?
Yes. Why not? Again, it depends on your interest, but whether it will be efficient, it's another question.
Oh, that's good. We like efficiency.
Because, of course, quantum computer is the first place designed for quantum problems.
Yeah, that makes sense.
And if you have in mind some classical problems, yes, you can use quantum computer for this, but it's like, using microscope to nail down the nails.
Yeah.
You can do it. You can do the job, but you can do it also in a more efficient way.
But, so I might at some point get like maybe a quantum plug-in chip or something for doing specific types of problems. Will I get a quantum accelerator, like I get a graphics card or something like that, if I need it?
Well, again, that's something we hope for, but for a narrow down class of problems. Yeah. And then, it's probably going to be a job for other people to broaden this class of problems, right? That's another aspect that people are thinking.
No,
is it time? Not yet.
It's okay. So I also think it's great that you come from like the academia side, and I feel like we who are working developers, we need to hear more from academia in general.
That's very good that you have this impression.
Yeah. No, but I feel like we get so stuck in our own perspectives. We need to hear more from everyone.
My own vision of this, that fundamental research is of course necessary, because that's something that drives big development, long-scale development. Yeah. And it's a pity that nowadays many funding agencies are really focusing on short-term goals that, of course, are more rewarding in short terms, but we also need this long-term perspective to evolve and to be sustainable in a very long time.
Yeah. So it's the differences in perspective, I guess. And I feel like that's really useful as well, because there are some developers out there who seem to have more of a sort of researcher's mindset, and they go away and you don't hear anything from them for 2 years, and then they come out and they've thought something through from the bottom up, and
exactly. Yes.
And that excites me. I would like more of that in
yes,
business.
But it's also risky in some sense, right? Because it means that you invest 2 years of your life, maybe 2 years also of life of your students, into something that might work or might not work.
Yeah.
That's a risk we take.
Yeah, sure, but maybe we should take more risks. Everyone doesn't need to take the same risk of focusing on AI.
Yeah, but if you try something risky, you have more chances to get something more exciting, right?
Yeah, exactly.
If you kind of try some small baby steps, of course the reward is also small.
Yeah.
That's as simple as that.
Yeah, so one of the themes for the conference is what's next. So if that's not part of of your talk, then what's next in your research area for you?
Honestly, I don't know what to answer, because the field is so fastly evolving, and that's essentially, it's up to us what's next, and that's exciting. But
that's super exciting.
It's super exciting, and I think the best thing about it is that there is a whole community working on different aspects of this quantum computers, on different platforms, on different ways to optimize it, and like we're all building blocks to make this happening. So what's next will largely depends on all building blocks, and I'm really excited to be part of it.
Yeah. Is there a lot of... I guess there's a lot of interaction between academia and industry in this, because there are a bunch of big companies working on quantum stuff as well, right? Like Google is doing a lot of stuff.
Yeah,
right?
well,
or they say they are.
All major players, right?
Yeah, of course. Yeah. Do you want to go set up? Or
let's probably time, yeah.
Okay, yeah, thank you so much.
Well, thanks a lot.
Big thanks for listening to Kodsnack. If you want to support us, leave a review in your podcast player of choice, or just tell someone who might like the podcast about an episode. And don't forget you can come hang out in our Slack channel. A link is in the sidebar right on our website at kodsnack.se. Once again, big thanks for listening. Talk to you later.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.